after copyright form.
There you go. All right. So I'm gonna turn that on so that we don't have to review it, because I think that's useful information. And I don't know. I reached out, I called, and I can't get to Jim. I sent him 2 emails too. So
That's fine. That's fine.
he may be tied up somewhere or what have you. But I'm sure once he gets here, then he'll have a million questions for you.
Well, he'll have a million questions, and he'll have a million ideas too. Jim is a real visionary that has a practical sense when it comes to manufacturing. So I'm sure it'll be good to talk to him. Hey, Spencer, can I mention one thing related to that example you just gave?
Sure.
So you're talking about equipment manufacturers. They're trying to provide the service to support their equipment. And heaven knows, in a place like whether it's Georgia Pacific or Cargill or many other companies, that's an increasing issue, because it seems like every company has their own preferred way of getting their access to their equipment. It becomes a real security issue. And I know that you understand that. And so some common solution that would be vendor agnostic is a wonderful thing. But the other side of that equation is, if you're a Cargill, Georgia Pacific, or go on and on, as a company, you may have hundreds, even thousands of plants. I mean, Cargill has 1,500. And the issue within the company is you've got some really important technology that you've developed as a company for many of those plants that are running. And you've got some great experts. The experts may be at the corporate headquarters and the engineering division. They may be in Efremov, Russia, or China, who knows. But if you could take that skill within a company and leverage it so that they could easily work with a local site person any place in the world, then that takes a resource that's special and unique and valuable and leverages it over many, many other plants.
That's right.
Cargill. So can your company help leverage internal resources as well?
Yes. So, John, you raise a good point and very astute observations. So we started with OEMs, companies like Bobst, who build machines, and our list of OEMs is long and strong. We work with, for example, Millicron, that makes plastics.
Right.
And Dur, who makes environmental controls. You may know Megtech formerly from Babcock and Wilcox. So,
right.
So those are customers of ours. But what we've seen now is that we're transitioning the business to point more towards those end users, because we've had some amazing success stories with end user companies like Westrock or Graphic Packaging or American Packaging, who are multi-facility, many facilities, have thousands of machines, and they have met us through our OEM relationships, but they've transcended. They've gone beyond the OEM relationship into direct relationship, where they say, we have seen what you can do for these OEMs, but we want to do it ourselves. So some of the companies I've mentioned, they actually have taken our design. If you come visit us, you'll see we have like a mission command center with a video wall, and on the video wall we have data streaming in from factories all over the world. And when these engineers visit us from large entities like Westrock, they see that and they say, oh, wow, we want this ourselves, because we can then in Atlanta have our best and brightest engineers working in a operations center, and using ei3's technology, we can not only monitor what's going on in these facilities around the world, but we can even get down to the operational level of the controllers, whether they be PLCs or process computers or drives. We can actually get onto these devices, and we can affect changes centrally from our headquarters. And so that's one of the reasons why I'm so excited to meet you and talking with Mark, is to help find these entities, these large end user manufacturers, so we don't have to go through the OEMs, because the OEM business model it's a good one, and I'm not saying we have any difficulty with it, but what we find with the OEM business model is that they only want to pursue their own objective, which is
Exactly.
to sell this technology on their machines. And if the competitors' machines don't get serviced with this amazing technology, well, that's too bad. The manufacturer shouldn't have bought from the competitor. But we have built a modular solution which is able to connect to different types of equipment. So whether you have a German machine with Siemens and it's an old one, so it's got Profibus, or an old machine made in Wisconsin, which has Rockwell Allen Bradley with Data Highway Plus, or a new Swiss machine with a Beckhoff or B&R controls with Ethernet as the I/O system, we can connect to all of those. And so by connecting to those, I call it a heterogeneous environment. We have built a modular data collection system that uses our secure network and connects from our data centers to these heterogeneous types of controllers, and then able to bring data from different sources into a common database. That's how we're then able to do these types of benchmark comparisons, because once we get all of the data from all these different pieces of equipment into a common database, then in the common database, we employ best practices. And I'm sure you're probably more familiar with the best practices than I am, but we like to use the things that Six Sigma and Lean practitioners use to benchmark and analyze their equipment. So we have an OEE engine, and that OEE engine supports different, because there's lots of different flavors of OEE, so we can, with no code, we can employ different OEE models so that the data that comes from all of this heterogeneous equipment in the factory gets to a common database, and then in the common database we apply the OEE analytics, and then we disseminate that OEE information to the owners and the operators of the equipment in the form of web pages, dashboards, and reports. And so that business description that I just provided to you, John, that is really aimed at the owner-operator, not at the machine builder. So like a company like a Cargill, who has, let's say, lots of reactors, and the reactors are coming from all different types of suppliers, and they have all different controllers, and there's historical reasons for that, and we're not going to get into why this one is better than that one. But Cargill, all they want to know is which ones run better. And so we can answer that question. And we answer that question by putting the same OEE algorithm onto the entire fleet of reactors across the plants all over the world. Now, we also, with that, we look at OEE, but we also look at the individual terms of the OEE. So OEE is made of availability, performance, and quality. So we have, again, with no code, and I keep coming back to no code as a key differentiating point, we have a no-code solution that will look at, for example, the downtime, reasons for a piece of equipment, and we will look at, there's really different types of downtime. You have the technical downtime, which means that something broke, and then you have production downtime, which means that you didn't have raw materials, or you didn't have sales, or you didn't have this, or you didn't have that, but it's not a fault of the machine. So we do a Pareto analysis of all of these downtimes, and we can gather the fault reasons from the controllers of the machine using no-code approach, or we have apps that the people at the facility, they can either type in the downtimes, or we can have through an API, we can bring the downtimes in from the local business system, the ERP system at the factory. But we'll do all of that, and then we can tell the vice president of manufacturing of Cargill, we can tell him what is the number one cause of avoidable downtime across a fleet of heterogeneous machines throughout the world. What is the number one cause of downtime that's avoidable on that fleet? And that's super valuable. And the reason that it's valuable is because that's going to give him the best bang for the buck of engineering return on investment of improvement dollars, because if you go to the Six Sigma school or the lean manufacturing school, they're going to tell you use the Pareto analysis method to find your top avoidable downtime, and then if you focus your time and energy on that, that's going to give you the best return on investment. So that's beautiful and great, but the problem is it's very difficult to know what's your top reason of downtime unless you have a common system deployed across your fleet of machines. So we have apps for quality, we have apps for performance that are similar to that as well. And I'm sorry, I need to rattle on like that.
No, that was great. That was great, because it started making me think of all sorts of things. By the way, that executive in charge of manufacturing for Cargill or any other company, for instance, Cargill spends literally billions of dollars each year on capital building plants, expanding plants.
Sure.
Now, if every time I spent $500 million building a new complex, I could install that complex with not only the manufacturing equipment, but the systems that were going to verify performance and assure me that the company got the return on the investment that was promised, that'd be a powerful thing. I mean, it's always that idea of the main thing is to keep the main thing the main thing. And the main thing is to know what's going on. But to do that, you've got to be able to collect information from machines and machine data, control systems. We have various systems that are collecting downtime information, planning and scheduling information that may be relevant. OCSoft PI systems, so manufacturing information. Can EI3 access those other systems to get that data?
Okay, great. Wow. Well, first of all, it's very cool to be talking to the guy who completely understands the value proposition that I just described. By the way, that's very rare. Usually I have to then go circle back and then decompose a lot of these pieces. So your question is fantastic. So let's talk about that. The internet is a revolutionary tool, and especially if it's used properly. And I do see that there's entities out there that are using it properly, and there's entities that are not using it properly. And I strive as much as possible at EI3 to use the internet properly. And the benefit of the internet that really comes into manufacturing is its ability to network things, to share information in a secure and controlled fashion. That is what makes the internet so powerful. It's not that everything's open and everybody gets everything. It's not a free-for-all, but it's also not siloed proprietary systems. So there are tools that are at the disposal of internet practitioners that can be leveraged to achieve different types of integration. One of which is the thing called the API, or the interconnection means using a methodology called REST. And what that has done is it enables you to achieve the ability to share data between two systems made by two vendors who absolutely don't trust each other, and they won't open their systems up to each other, but they will share data on behalf of themselves or third parties. And so we do that, and we've done that, and we've shared data with many third parties, for example, SAP. I don't think we have an example, although perhaps with WestRock, we've done it with the OCSoft, where we've been able to move data in and out of their system using their REST connectors. But the principal design is there, and if it's one of these things that you have a vendor who is willing and able to have this open interface, then we're able to take it and run with it. If the vendor says, no, I've got this is closed, I'm not sharing with even with my customer, in those cases we have difficulty. So long answer, but I hope that answers your question.
Well, it does answer the question, and opens up some really interesting possibilities, so appreciate that. By the way, I see that Jim Davison is on the line there.
Hey, my neighbor decided he wanted to tap his emergency generator set in today, and the only way to do that was to shut the power off for the whole cul-de-sac. And it's like, oh, I'll still get in because my laptop has batteries, but my my web access does not. Sorry about that.
Well, I hope you had success. You're safe and well. Safety first.
No, it wasn't it was his generator. It's like, oh, well, I can't wait to do this to you. It would be good to have told me. Of course, I didn't know. I didn't know that they had to take the whole grid down to tap it into the source point.
This is like the real manufacturing world, isn't it?
Yeah. Sorry about that. I do apologize. It's like my phone is beeping. Oh, okay.
Well, Jim, we recorded a portion of this so that you could watch what you missed. So I didn't know when you were going to get there, but I thought it would be useful at least to have some documentation of what was covered before you got online here.
Thank you.
And hello, Jim. This is Spencer Kramer. It's a real pleasure to meet you, and many thanks to Mark for pulling this meeting together. John and I were having a very interesting and detailed conversation about really starting from the heterogeneous equipment on the shop floor and bringing it through to the cloud and doing benchmarking analysis of equipment performance and then sharing that data with open systems. So yeah, there's a lot was discussed, but you know, really happy to have you join us here today. And if you want to have a personal conversation to catch up on some of those things, also you and I can have a phone call or anything like that to talk about.
No, that'll work. That way I don't detract from this. One of the one of the points that I brought out the other day when I talked about you know, when I first sit down with a supplier and we're trying to figure out, okay, what is your niche that you're better at than anybody else? And then what do you have to do in your business to make your niche work? Meaning, so I always ask first thing when I deal with a supplier, do you make a product or do you make a solution? Because a software product organization tends to operate in a whole different manner than a solution provider. And so as I looked at your product and as Mark had told us several things about it, I said, well, it looks like a really good connector, secure, capable of moving large amounts of data into a cloud environment through multiple sites so that, and I didn't know whether you had the analytical tools to plug into it or that you allowed for analytical tools to plug into it. But the thing that I worked on when I designed a lot of the Cargill strategy systems was try to find the best of breed, put that where it needs to be, and then try to figure out how do I get this particular product to interface with, for example, the best of breed product for a workflow engine, okay?
Sure.
Or an analytic tool that allows for analysis of the data that we need to, versus force the guy that made the really good widget to add on a bunch of stuff that they may not be comfortable with supporting in a 2 to 3 year window space out. So that's why I had asked for the call to get a feel for, okay, what is the product? Where's the product used? What do they believe is their, what sells them into the solution market? Or do they want to be the solution market? And if so, how will they run both of those businesses together? And if not, are they looking for having us go out and look for solution providers that you would fit neatly in with some of the packages that are being developed with some of those guys out there today? So that was a big push that I had. And if you've already covered it, great.
No.
I'll follow the video, but that's where I start off with. It says, okay, what do you want to be when you grow up? Okay?
Sure.
You want to be a solution provider, or you want to be the best at building tools? Because when you think about it, the end consumer the guy you're selling it to ultimately doesn't want to buy a software product. They want to buy a solution.
That's right. That's right. So that's a great, that is an absolutely salient question that speaks to the core of business, and wow, what a way to get started. So nice to have this opportunity. So Jim, I come from the background of delivering custom solutions to machinery OEMs.
Okay.
In the 1990s, and that's actually when I met Mark Fondel. I had a company which you would recognize as a systems integrator. And I bought products, a lot from Siemens at the time, and I put them in big control panels and I shipped them around the world. I had about 150 people working for me with 4 offices and so on. I provide that to you as a point of background so that you understand that I am an industrial guy. I've tuned drives. I've everything from oil tankers at sea to dynamometers testing jet engines. I built the drives and controls for that. In the late 90s, I became obsessed with the internet and had a kind of an aha moment where I realized that all of this data that's available inside PLCs and drives and process controls, computers, if you connected it to the internet and you created secure pathways that you could liberate the data and create an enormous amount of value with the same data that was being isolated and trapped on the machine. And it was so profound that I sold a very successful business, pivoted my career, dedicated my life to this, and have built ei3 Corporation. And here I am now talking with you. So,
no, excellent.
Yeah.
One of the things that when I look at things like the MindSphere and those collectors and pushers, I call them, is the concept, and Cargill, we were dealing with this a lot. I call it the concept of little brother, big brother. And they're both components of the same software firm, but yet the big brother has all the power. The little brother operates within the plant environment, and depending upon what you want to do with it, whether you're trying to do real enough time control, whether you're trying to do analysis, and I watched this happen with like OSI Pi, for example. You would go in and originally it was put in to collect data, do analysis, and then after a week you'd look at it and you make some widget changes.
Okay.
And as people consumed it more and more, we would still push it to the cloud, but we became very dependent on little brother, the guy in the plant, to be able to make decisions in case we went untethered. Now, Cargill was 950 of our plants were connected with something that was probably lower level capability than what's connecting my home today. A grain elevator out in the middle of nowhere. So we would lose, we would lose our tethering to the big system, and so we had to determine how we become non-dependent to run, because there were lots of surprises. I still remember one time we got a call from a plant in Australia and said, "Hey, we can't unlock these tank valves," and we found out that someone had linked them to a lab system, and then when SAP came online, it saturated the bandwidth, and we lost our tethering capability, and it was miserable. So it sounded like, and what I looked at in your product is you have these two strengths. You have the strength to capture and do work at the plant level, while ability to synchronize it and do larger capability strength to data at a higher level.
So correct.
Or multiple site comparison, we'll call it. Okay.
Yes. So Jim, absolutely. So just to backtrack a quick moment. So coming from the background of making solutions based on products in the 90s, we came up with at ei3 this notion that there would be a big demand for the different products that you would put together, that OEMs could integrate themselves to create solutions. And that's what gave to this genesis of what ei3 is today, which is a collection of products, some of which are hardware that sit on the factory floor, and other is a product, it's a software as a service that we run in the cloud that does no-code IoT analytics. And the idea is that we have partners, and our partners include companies like Lenza, which uses our product as their version of MindSphere. They sell it to the OEMs, and those OEMs sell it to the end users. They put their own brand identity on it, and they resell it at a markup to the marketplace. So coming to that point, so now your question or your point about tethering and not tethering and so on, and giving the factory the ability to continue to operate if there is an internet outage. These are issues that we've talked about and addressed with our customers over the years. And I'm not going to pretend that we have any more experience than you, because it sounds like you've been doing similar things for many, many years. But what I would say is that we do have a hardware device which we put into factories, and the hardware device has a local independence. It can operate on its own. We have a new one that's coming out next month. It's very high performance, quad core, gigahertz, processor frequency, 32 gigs of RAM on board, static, that you can store local data, gives you ride through if the internet is down capability. Also has a lot of, we do a lot with predictive analytics, so we can do Fourier analysis and take vibration signals or other signals and do complex algorithms to then affect local changes in an untethered case.
But still allowing little brother to synchronize back up with big brother when it can, to re-optimize itself, so to speak.
Yes, exactly.
Okay.
Yeah. So if you've looked at our webpage, you've seen the Amphion. It's that little black box, and that it's based on embedded Linux. It has a lot of pre-configured features, and it also has some available processing capability and memory that a systems integrator or OEM could put to use to do their own special things as well. And we look at it in both cases. To come back to what John and I were talking about, where you have an enormous fleet of machines across hundreds or even thousands of factories, the thing that makes us unique and valuable is that our Amphion box and the supporting cloud that merges with it is an a working set of products that can get those factories networked without having to send a specialist to each and every factory. And we've proven this because our OEMs, and one of our OEMs that we work with, I mentioned earlier to John, is a printing machinery company called Bops, and we've been working with them longer than anybody else, since about 2004. We have about 5,000 machines connected with them in 3,000 customer factories at about 100 countries around the world. We at ei3 have not visited maybe 4 of those factories, and we only went to those 4 because it was in the early year. We were like getting the original demos going. They've been able to integrate them completely themselves. They've been able to give the machines names, define their maximum speed, locate the customer address, determine what the OEE model is, and get the data as well as the secure access to their 200 people, which are all working in Italy and Switzerland and France, connecting them to the machine base where the hierarchical permissions are maintained, all of this without any software code from us. And
so they're using your tool set.
Exactly.
And then they make the connectability themselves. Okay. No. I understand then. And that was that video that I saw on the paper machines. And paper machines, based on some of my experience in the early days, a paper machine going down is big money.
Oh, it's horrible.
And so 1, you don't want it to go down. And 2, you want to be able to do a roll on, roll off, to do a swap out very, very fast. And 3, the more predictable you can make it, where you can actually schedule it out, is so much better. I mean, we sold, I said we sell, but I'm no longer there. But we were working on small fiber corn fiber for the paper industry. So I was getting back into utilization in the chemistry side. My background is both chemical engineering and electrical engineering, so I live in both worlds.
Okay.
So the thing I thought about, John, and I direct this to John, was think about our problems we had with Stork Morel.
Mm-hmm.
And we have, Stork Morel makes probably 8 styles of systems when we use in our poultry business. And we have our poultry businesses in China and Thailand, but it's the same thing. It's the harvesting process, it's a defeathering process. And it sounded like on a smaller scale, these were components that could get in, and we had the worst time trying to figure out how to get a tool in between Stork Morel machines to talk to each other just on the site, and Stork Morel harvesting machine in Saraburi, Thailand, to know how to talk to the new one we just, and compare themselves to the new one in Santo Tomas, Batangas, Philippines.
Yes, sure.
And all of this was being just, and John knows, like most of us working in a poultry business, the last 2% of the meat you take off the bone is your profit. If you don't get that, and most of the material is removed by human beings. So a chicken factory will have 10,000 people with knives, and they'll be cutting.
Right.
And you need real enough time feedback to those people to tell them they're doing well or not doing well. Because if you wait till the next day, all you know is you lost this much money.
Right, and you have the next 3 days to recoup what you lost on that day.
And then sometimes what you do in like a very low responding control loop, you overshoot. And now you're getting bone structure in your customer base, which isn't very good too for the. So anyway, so that's what I started to compare. It says, okay.
Hey Jim. Jim.
Yeah.
Jim, let me just add one thing. When I was working at Purdue, Jim Purdue, who owns the company, once said about deboning, to emphasize your principle, he said, if you don't know until the next day how well you did in deboning, you're running a hobby, not a business.
Yeah.
So you want to run a business here.
Yeah. And the thing that we saw, it really has an impact in our hamburger business, which is similar, was that what would happen is the bearings, for example, on the blenders would fail. But you would not see it a failure of a normal bearing because they're very low speed, but the way they would fail is they would just drop slightly. And in that slight drop, it would scrape the stainless steel of the blade with the tank. And all of a sudden you got the non-ferrous problem in your meat. And we would have to take a plant down, take 2 days of material, rerun it through these very special magnetic filters. And we were never able to, we could do the analysis, okay? Yeah. We could find the pattern with a company like Seek to say, okay, when this and this and this happened, but we couldn't get the communications to occur and share it amongst the 300 blender machines we had across all of our sites. So these were the ways that I was trying to say, okay, how would I best consume that component of the product to make what I have or my thought process is better? So if I'm on the right track, great. If I'm on the wrong track, say, no, Jim, that's really not what we do. But these are some of the ideas of that immediately came to mind for me. It says, okay, how could I use this to make Cargill money?
Right.
And do it over 300 or 400 systems so that I could set up a commonized approach to put in a whole bunch of them, like 50 or 100 units per quarter. So that, if you put one in and you put one in over a year and you have 1,600 plants, you never finish. You know what I mean? And so you also have to model it so that you can commoditize the installations. So it can't be just one system that really goes for a lot of bucks. It's got to be one system that immediately starts producing, and you use the profit share and the value share from that to invest in a whole series of other enhancements or improvements to it. And then once everybody learns, then everybody jumps on. But you got to be able to deploy anything that we were looking at. You have to be able to deploy 50 to 100 units over a quarter.
Sure. So
those are the models that come to
point.
mind when I'm working on stuff.
Yeah. Well, and I think what you've just raised as a point there really speaks to our approach, because look, even in the 1990s, there were routers and firewalls and things commercially available that you could connect machines to the internet, and you could be sitting in your office in Chicago and see a machine in Thailand. That's been available, and it's doable. The issue that I saw when I got started with ei3 was that it wasn't taking the commoditized approach. You can hook up machines in factories, and people do it. And I go into conference rooms every other week, and I talk to people who have done this in ways, and they have to have router specialists and project plans and involve lots of people. And in the end, you could maybe, they can do a machine, they could do a factory maybe in a month or something like that.
Yep.
And absolutely, it's very secure. There's nothing wrong with it. It's doable, and it works. But it's
high cost too.
It's high cost, and it's not scalable.
Right. It's all custom.
It's all custom.
Yep.
In order to do what we do, where we're putting on right now, while I'm sitting here, there's probably 3 or 4 OEMs at different parts of the world are putting machines online right now with ei3.
Okay.
I don't know where they are. I don't know what they're doing. I don't know anything about it, but I know that it works. And it's being done with no code. It's being done with configurations and configuration files of hardware devices that are lockstep keyed, and there's no security holes being made. They're lockstep keyed to our servers, and our servers are working in 4 locations. We're backstopping the servers in 4 locations are actually clusters of hundreds of servers, which are connected on a secure private network. They're backstopping each other, and it's giving the OEM who's setting this up right now a trustable platform that they can go off and do their own data benchmarking, scaling, comparing, reducing their warranty costs, or selling services to their customers that they couldn't have done otherwise.
Okay, I understand.
So, yeah.
I understand the value and how you capture the value for your company from the and then what you do is you make the product better, faster, quicker, safer, lower cost.
Right. For a dozen OEMs, and each of those OEMs, they're billion-dollar OEMs.
Yep.
By the way, we're talking to Morrell now. We haven't gotten any business with them yet, but we're in conversations with them, and in Iceland. And but those OEMs, they could not afford to build a solution themselves, because even though they're a billion-dollar OEM, it takes a big team of developers and infrastructure and everything to make it work. So by having a group of customers all coming in, we give them a very good value.
Okay.
So that's the business. In a nutshell, that's the business. Now, when you talk to a Cargill or something like this, and this is what John and I were talking about just right as you were coming in, Cargill has an interesting, and this is happening to lots of companies, where now the OEMs are waking up to the value of connecting their machines, and they're coming with a new machine, and they're saying, we're going to deliver this new machine to you, but we want you to put this box on the new machine, and this box that you put on your new machine will allow us to service that new machine remotely. And we'll get data about it, and we'll be able to give you a better service and a better support, and maybe we'll even give you predictive and all other things. The problem with that is, and a lot of companies, especially in the food industry, are wrestling with this right now, is it's a very seductive value proposition, but do you want, if you have a factory, a greenfield factory that has 20 different machines from 20 different companies? Do you want 20 different holes in your firewall going to these 20 different companies where you don't have any control over when they're accessing the machines, what they're doing with the machines, and so on? And they'll say, oh, relax, we have a key switch. We'll isolate it with the key switch. Your maintenance man will know when it's connected. And
yeah. 2 o'clock in the morning, everybody's turning key switches. Yep.
Exactly. It doesn't work. So we've adapted our solution, and we've adapted it from very big companies in the paper industry, that you can, instead of it being an OEM-centric portal, we can make it your portal. You can make it the Cargill portal. And you can say to the OEM, oh, we're very happy that you understand the value of remote access to machines, but we're going to give you access to our portal. And you will log in, and we can give to you the same type of micro-segmented network that you would have if you custom engineered a solution through your firewall, which some companies do. And a lot of people are doing this now because Google and Cisco are in bed, and they're doing these things. But we can give you that same kind of micro-segmented firewall. If you use our black box, we can give you at a factory, or you can be sitting at the corporate headquarters, and you can say to Morel, I want you to service the machine in Indonesia, all right? And you can using a web page, you can go and you can click a key, a little icon of a key, and you can create that pathway for them to use, and they'll only be able to do it for 4 hours. It automatically self-destructs.
So, John, this sounds like playbook number 3 for the project that I was working on just before I left.
You know, it's
conceptually, so not with the tool, but with the concept.
It's a common need. Yeah, absolutely.
So we were developing, utilizing a different product, but the same concept. We wish to control the access. We want to control when that access is turned on and when that access is turned off.
Sure.
We want to control who can access and to what point within the system that access will go to.
Right.
And so we were interfacing with a German company, not Siemens, and actually in the midst of conceptually reworking some of their firmware in a small little box that we would stick in the system that would allow them in and out of their particular component. Okay?
Right.
But it sounds like with your product, we actually would be online with it anyway. Cargill would be, or the company, the owner's company would have access to it, and we would give them to this. Let's say we were collecting a multitude into a database that we controlled, and we would allow them a port into the database, not into the machine itself. And we could trigger it so it would get real enough time data coming into the. Here was a problem we were trying to solve. So we have in a multitude of plants refrigeration compressors.
Okay.
And we might not have the best mechanical guy on every site, but yet when a refrigeration compressor, say a 400 or 600 horsepower unit goes offline, it would trip, say, a vibration or trip a system. We found that in 20% of the cases, when they tried to do a restart, that they could potentially do more damage to the machine than if they had just done some diagnostics on it. But yet we could never get either the OEM or our chief. We wanted both. We wanted our chief mechanical guy or team to look at it, and we wanted the OEM to look at it so that they could say to the plant within a 15 to 20 minute window, it's safe to start that machine again. And so that was one of the gotchas that was a big payoff for us if we could make it happen. And so that's, I go back into the world of where can we save money? Where can we make a better system? The other thing was that we had this other little block we were putting in to the highways was access into burner management systems, access into propylene oxide safety protection systems. How do we keep only the right people in those systems to make any type of adjustment or any type of change?
Right.
And so
we have so what you're describing, the problem at a high level, what you're describing, we have that hierarchical and granular control built into our system, and it's built in a way that the little black box, which you've seen online, is programmed using web pages. There's no code involved. It's configured using web pages, and you would set up the OEM that you want to allow to access it, the service office, and the plant personnel. They're defined as groups. And then you'd populate the permission to access that by these different groups. And inside the groups, you have all the different people, so that if somebody leaves an OEM, he is immediately shut out. He doesn't, as soon as he is gone, he can't access equipment for safety reasons.
But they would access the appliance, or would they access the actual, say, processor in the unit?
No, they access. So what they access, Jim, is they access our secure gateway in the cloud. And our gateway in the cloud then allows the route to be made from a technician, wherever he is in the world, to the machine.
Okay.
And so we can integrate, for example, if you have an Active Directory at Cargill for your employees, we could loop the Active Directory in.
Yep.
But the OEM may just have a list of approved people. So they would have to keep their list of approved people up, and your Active Directory is kept up. And the intersection of those is what allows people to get through.
By ID. Not a Omnicom general. It was by personal ID.
Yes.
And we could restrict it on the basis of timing and hours and okay.
Exactly. Then what happens is that the plant so all of this is set up by somebody who is I will call it a systems integrator.
Right.
And that's why when we were dancing around this notion of the integrator. We need integrators. Okay, we need integration partners because we're not set up to do this work. We can do it, but that's not our role. We want to sell.
You don't have the 300 people dedicated to toss it, that type of stuff.
Correct.
Nor do you want to cover that overhead. Yep.
Exactly. And it doesn't make sense because the integrator has a relationship with the manufacturing plant, and we don't want to change that. We're not trying to replace that. We want to work with that. So now the integrator, we teach them how to set this up. The integrator configures all the machines, and they use the black box, and there's no security loopholes. There's no mistakes. It could be Friday, before a 3-day weekend like now, and you can set this up. And if you get that machine online, there will be no security loopholes. Whereas if you went with, say, an open Cisco appliance, you might just say, oh, gosh, I got to catch the plane. I'm just going to open everything. I'm going to be out of here. And then there's a lurking time bomb that.
Yeah. Yep. I'm getting a better feel for your strength because we searched for, John, how long do we search? 6-9 months for this capability. We weren't able to find it.
I was going to say that search has been going on for multiple years.
We tried to do. I tried to work with that MindSphere thing, and conceptually they were okay, but it was way too open and way too expensive for their little appliances to get data movement in the system.
Yeah,
Jim, you should have talked to me.
Yeah.
I should have talked to you. Sorry about that. Well, buddy, I knew about the other stuff you were working on conceptually.
Yeah. So,
okay.
Where was I going with that? So that's how we can then set it up that the plant manager.
So let's talk about the access. Okay. So now we're in the cloud. We've allowed this technician to come into your cloud. That's connected. So the appliance is connected to the device.
Right. The appliance is connected to what controls the machine.
Okay. And then
go ahead.
That's connected to the cloud.
It's connected to the ei3 secure gateway. Yes.
Gateway. It's into so I'm the technician that's requesting the ability to go in, and let's think of two scenarios. Scenario number one.
Okay.
Most of the time, I would say 80% of the time when a system fails, it's because a component out there has failed and your diagnostics is not good enough to figure out what's broke that I need to go out and fix so the rest of the system can start up again.
Okay. Okay.
And the second one is a scenario that's built on the fact that, yep, I've identified what's broke and I don't have that part in spares. Can I safely put a little jumper around that for a period of time so that I can at least get the system in a stable or steady state process?
Mm-hmm. Right. All right.
But, so one is, I just need it for identification of what's broke and what's stopping the machine or the system from running. Mm-hmm. The other one is, can I jumper around it and is it safe to do it?
Okay. All right. So I'm not going to throw up a block diagram because I think everyone. But you understand. But let me explain a little bit about what the ei3 solution is. So we have our little appliance. We recommend to put one on. Sometimes I'll say these are like doors with locks. The little appliance. Okay. So if you have a whole factory and it's all the equipment is from one OEM, you could put just one on the whole factory. But if you have a factory with machines from 10 OEMs and you want to segregate it, it's just like if you're coming to the architect, I say, I want to have a locked door for every department of my factory. Then you put 10 of the appliances on the factory, okay? And that appliance then connects to the controls of that machine or that area of machines, okay? It has a lot of little features I won't bore you with, but for example, it does natting. So if you have 3 machines on your factory floor where they all have the same addresses, the appliance nats them into unique IP addresses so that we can globally, through our global network, we can get to just that one machine. Okay, So now, what does it do? So for security purposes, it only makes an outbound connection. It will not accept any inbound requests, okay? So if you put it on your factory and it will make an outbound connection, it will only make the outbound connection to an ei3 data center. 2, actually, a primary and a secondary, so that if the primary is down or the IP address is down for any reason, it goes to the secondary. So it makes
it won't accept a call,
no.
But it will send a call.
Exactly. Right.
Okay, so it's using the callback feature. Okay, good.
It only goes outbound. All right. Only outbound to us. And you can set that up with your firewall so that you can also just throttle it so it will only go to us as well for your own assuredness. All right. Now it gets to us and it establishes a secure tunnel from the machine control area to our cloud.
Okay. So now when you
two things are happening, and this is what makes us really unique. Okay, this is where it really gets. We use that tunnel for 2 purposes. One is we use it to collect data. Our data collectors, which support heterogeneous, and we write them ourselves. We don't partner with Kepware or any of these other companies. It's our own data collectors. They support native Rockwell, native Siemens, native other calls. And they go in and they get the data from the controllers and they put it in the data warehouse. That's one. But 2, through the same channel, we allow secure communications for programming tools. Those programming tools can be the Step 7, it can be the Rockwell, Control Logics, it can
That was my next question. Can I then, once it's called back to the data system, it's established a tunnel link, and only a tunnel link to that, say, that PLC.
Right.
Then the individual, the technician on their laptop that...
Well, wait, we haven't connected him yet. That's not connected. It just goes to the ei3 cloud, right?
So I'm in the cloud.
Yeah. Now on the other side of ei3 at our data center, we have a very special firewall, which... we go to the technicians of the world and say, with this, which is our own security center, if you have the right username, password, and token, if you have those 3 things, we're going to open a channel on our firewall for you that we're going to connect you to a particular machine in the world. And that
only tunnel them to that machine, to that PLC, for example.
Only to that PLC of that machine.
Okay.
And that control is not done by programming. It's done by your Cargill plant manager.
Okay.
So you can say, you can say to Franz at your OEM in Germany, Franz, I need you to connect to the machine in Indonesia. I need you to do it on Saturday morning, and I'm going to open up a path for you to do it for 4 hours on Saturday morning.
Yep.
And there's no programming, there's no call to IT, there's nothing. You go to a web page, you set that up, and you hit send. It will send the email to Franz. Okay, Franz will get his username and the token, but you have to call Franz to tell him the password. Just in case that email goes to the wrong place, we don't want to open up a pathway to your machine that went to not Franz, but it went to Franz H instead of Franz K or something, and it goes to the wrong person. That's a big problem. So you have to call Franz and tell him the password or send it to him via other means, text message, maybe even another email. But that's the second factor of the two-factor authentication that he has. So with that method, then you can have the trusted third party get to a single piece of particular machines in your factory under complete control. Then that action of Franz connecting, we audit it. We monitor it and audit it and report on it. So you know that he was there. We know where he came from, what his IP address is, how long he was there, how much traffic was, all those details. And then you can pull a report out of our system so that you can then see what had happened on that particular piece of machine.
So let's say I want to go in and modify a Rockwell PLC system.
Yeah.
Okay. I followed all the rules, came in. The software that most technicians are going to have will reside probably on their laptop.
Yes. Right.
And so all I'm looking for is a secure tunnel from that individual's laptop through the proper firewalls to that particular PLC with only ability to see and upload that PLC and not go anywhere else in the system. And so that's the uniqueness and the capability strength of the product that you have then.
Exactly. Okay. Now, let me take it one tiny step further. Bill.
Okay, good.
You're a controls guy, so you'll get this. So when Franz logs in to ei3 with the token that we gave him, the plant manager gave him, he will get what I call a service navigation console. And on that service navigation console, he'll see some basic facts about the machine, just for sanity check. This is the number 3 refrigeration compressor, and it's in the Wichita, Kansas facility, and it was made in 2005. And then there's a tab which will give him the exact coordinates he needs to put in his Rockwell programming tool. It'll say, to get to this, you need to use ControlLogix, and you need to use the IP address because it's a local network, right? It's not you need to use 192.168.2.1 for your default gateway and your subnet of 255.255.255.0 or whatever.
Does it recheck it and give them a MAC address check, which we ran into? So with Cargill having 1,647 factories around the world, we found out that we have used the same IP address many times. And unfortunately, we get into a race. So we may think we're in the Crusher PLC for the plant in Shanghai, China, and we're really in Indonesia, and it can really mess up the system. We ran into that issue before.
No, I understand. So we don't have an actual MAC address verification because, we've never been asked to do that.
No, that's okay. That's okay.
To say that we couldn't do it, we could do that. There's an easy add. What we do know though is that with the service navigation console, we've reduced that chance quite a bit by
because they're making a check to a at least a feedback check to, okay, I'm in this plant, I'm doing this. Okay, no, that's good.
Yeah.
That's good.
Yeah. So then with those coordinates that we provide, and by the way, that's the integrator who sets all of this up will need to know the IP address of the PLC and what PLCs are on what machines. All of that, we trust that our integrators know that stuff. We don't put that in. That's put in by the integrator. The integrator does it so the plant manager can send the key. We call keys. The service session door is opened by a key. The plant manager sends the key to the third-party service provider. The third-party service provider then has all the information he needs to connect in to the PLC. Does his work, all of the traffic is logged and audited. Then there's also, at the close of the session, we have a notes field which we require that they put in information about what they did. And we also have a quality of service where we track, we say, was the internet connection good, medium, bad? Because we also track quality of service, we have a full Q of S feature built into our platform, not as good as what Mark was doing, but with his software, but we ping and we measure latency and all of this to all the devices that we connect to so that we can give the service provider feedback about the connectivity of
No, I understand. I'm getting much more. I apologize for sucking up the rest of your guys' time, but yes, I'm absorbing this on the product. So what about, remember, John, the immediate failure we detected with the tunneling that we were doing with the other product, where we could spoof it, and I spoofed it within 12 seconds, and all of a sudden broke every security rule possible in the system.
Destroyed all confidence in that tool, right?
I did.
Yeah.
One of the things that I was really good at was breaking stuff. So, but breaking it before it needed to be broken.
It's really dangerous to be. We have to be careful then.
Yeah. No. I always believe in a process that says I'd much rather test those scenarios that I've developed over the last 40 years.
Yeah.
In a lab than I would at 2:00 in the morning when my neighbor has decided to hook up a new generator set and take the power down in the neighborhood. So yeah. Okay. No, I am now getting very comfortable. I mean, a lot of people sell stuff, okay? And it's like, here is what you gotta have and what you need and all that. But you don't get down into the real nitty-gritty of why this will solve these particular problems, and then what is a native part of the product, and then what are the add-ons, and then maybe so let's talk about, so that gets me in. So I can use the Rockwell software, I can use the Siemens software, I can use the software designated for that machine, and I'm not limited there.
Exactly.
I can collect data and put data into databases, whether I'm using a OSI Pi database, whether I'm using, and I can use a workflow engine on that, as long as, so I'm just simply moving around. One of the words that we started to use, and John, were you still there when I came out with ACE?
Nope, that's new to me.
So
what's
ACE, and I because I don't know whether I came up with it there or whether I read it, but ACE stood for, I moved from operational intelligence, which people started to make up all sorts of stuff on, to the autonomous connected ecosystem.
Oh gosh.
And that was ACE.
Down.
And so I was beginning to say, okay, we're going to now deploy more than operational intelligence. We're going to deploy the autonomous connected ecosystem. So and this is like, Mark, when you were talking a little bit, if I need to get the temperature of that day and the humidity to determine and correlate that with a package system that allows me to fill a dry product in a bag, and I'm overfilling the bags, well, my ACE system, if it's designed right, would be able to bring in that data from whoever it is to this central pool and do it on a secure basis. And what you're telling me, Spencer, is you provide the appliance, the box, the capability, the whole solution to
Structure.
how to move the data from that point on the shop floor to the individual or to the next level of
Next step.
software that you wish to deploy against it to determine whether you need to change a bearing. You can push it into a PM, a predictive maintenance system. You could push it into an analysis system. You could push it into, in our chicken plant, you could push it into our system that says, okay, over the last 10 minutes, you have been achieving your goal. So you have a green 96%, 97% on your tally board for your chickens. So everybody's going to get their bonus. So yep. No, this is good. I thank you for waiting for me on the call. You can tell I'm getting excited about this. Yeah. So
hey Spencer, let me interject one question related to that. I mean, it's eye-popping opportunities out there in the manufacturing world for such a tool, and that makes me think of the vision I read on your website, which said, "Become the leader of industrial internet services in the packaging and plastic industries." That sounds confining. What we're talking about is all sorts of industries. Have you expanded your vision, or are you focused on those two?
Yeah, and I need to come back to that. So we really have expanded our vision, and this comes out of some deep thinking that I did last summer. So, and it's partially the reason why we're also here with Mark and so on, is that we have done a very good job in the package and plastics industries, and in North America especially, we're with the 3 of the 5 largest package making organizations. I've mentioned WestRock, I've mentioned International Paper, Graphic Packaging. These companies use us pervasively across their fleet of machines. So now it's time for us to start looking for growth areas, and we're really believing that because now we have success stories that we can share, and I can have this kind of discussion, that it makes more sense for us to go directly to the owner operators, i.e. the Cargills of the world, than the machine builders. And the reason for that is that the owner operators, even in the plastics industry in 2005, they wouldn't talk to me, but Bob's, the machine builder, would, and that's how we got our bootstrap process going. Now we have loads of success stories with industries that people can look at and say, oh, well, yeah, if they're doing that with, bag making machines, they could probably do it with chicken boning machines. They can make that leap. And so we are targeting additional industries.
Makes sense then. That's
but
good.
I have to go back and update the website, so thank you for that.
But I think you got to go in arm in arm. So if you're going to approach like a Cargill, Cargill's there's going to be 8 people in that company. They're going to be able to make that mental jump from the paper making machine to the chicken machine.
Right.
There's not going to be a lot.
No.
Okay. And so you've got to go in with you'll have a whole herd of people that will tell you can't do it because of this or this or this, or how do you do this, or how do you do this, and that'll come out of the IT organization. But you've got to go in arm in arm with an integrator that knows Cargill too.
Exactly.
That's the other one that says you have. And it took me a while you saw me questioning and pushing and trying to extract, and I'll do more of that. Okay. But then I'll sort of whiteboard it out and I'll figure out how I would consume it. So I'm trying to figure out, if I'm Cargill, how do I consume your product?
Well, Jim, this is one of the reasons.
Sorry, Mark.
Mark, hi.
Okay, my bandwidth is kind of weird. I should have an interview on here to figure out why I'm having this problem. But that's one of the reasons why I brought this group together, because my conversations with Cognizant and what they're doing with their SLA and whatever, and the question of using them as the deployment arm in regard to that, and the requirement of systems integrators, I think is clear. And also, I think integrators like Omnicon and others that you're working with, Jim, this could be an extremely useful element to make ei3 successful if you're now targeting end user locations. And I believe maybe even Spencer got a call from Eduardo here recently in regard to that.
Mm-hmm.
Yeah, I was talking to before I even knew your product. These were some of the things we were working with Eduardo on.
Okay.
But the difference was, and I don't want to say good or bad, but given on their own, see, what Eduardo tried to do is build his own product. And I said, no, you don't want to build a product, Eduardo. You want to build the ability to get into 10 industries to use your 250 people to deploy the best tool out there. You can't build the best tool. There are people that are way smarter than your best people out there that are really good at the tool. And you let them work on it because they're going to support it, they're going to maintain it, they're going to sell it in block quantity, they're going to, and
they have a momentum.
So don't build a workflow engine. Don't build the secure network. Because when we came to him with the product that we were trying to generate with Phoenix Contact, okay, their MGuard.
Yep.
Okay.
Yep. I have one here.
And we were trying to modify it. We said, okay, this will work on the secondary side. When we went to the checkpoint component, we found out the checkpoint component does nothing. I mean, it's like it's an IT solution, but man, it's not working.
Where you want. Well, I know the MGuard.
It can't even generate a tunnel, whereas the MGuard, it generated a tunnel. We got it to work. It passed almost every one of our tests, and that was the one that I was able to spoof in 15 seconds. So I said, go back, guys, because and everybody's building out that appliance right now. So they're doing it. Siemens is trying to do it. Oh, who was the other guy? Wago. All these little guys are starting to build those out, and I'm saying the only thing that's going to be good for is putting a $2,000 to, if you first of all, you got to get it off of $2,000, but you're only going to protect a unit, and the nightmare you're going to need to figure out who can get in, who can get out, and keeping those records right is going to be incredibly difficult. That was what we ran into and said, okay, if you have 2 plants and you want to do this, it works great. But if you have
exactly correct
30 plants and you have 10 technicians in each plant and you have 4 different, okay, you now have to control and manage like 12,600 points of data because that's what you just did to yourself. You just did this pyramid thing. And people don't realize that because they think about one plant. They don't think about all the plants. So no, I am...
You're 100% correct. Our experience, we have MGuard, we have a dozen other appliances and their networks here. We look at them, we understand. And the reality is we have the scalability to put an entire fleet of Cargill online. Whereas a lot of these other solutions, they're great for the engineer in his cubicle with a point of proof of concept for one machine, one factory, but you're not gonna be able to put a global network of machines together on many of these systems.
The other thing that we worked on, especially around the workflow engine concept, was we don't want to take our things down offline in order to upgrade. Okay. But we don't want to build redundancy. And so in some of our design that we worked on with a workflow engine company called Savigant, they were local up there in Minneapolis. We actually deploy objects, and then we have a library system that knows where all these objects are and how they're all connected. And so if we make a change to an object, during the next workflow cycle, it makes all those changes in the system.
Wow.
So you never reboot or change anything. It's sort of like in the early days in PLCs, it would put the system into a stall mode, and then you could make the change, and the next time it went through the rungs, it would all do it. We were able to capture that, and because this workflow engine could do, at the time we worked with them to develop it, it could do like 100,000 workflows in less than a second. And so we actually helped them redesign their tool to do some of this. So those are some of the other concepts on how do you upgrade your system? And if your upgrade of the system is push a button and everything is upgraded and there's no downtime or stopping time, that's great for the continuous manufacturing, because a corn wet mill only gets to go down for 3 days every year and a half.
Oh gosh, wow.
Yeah. So paper machines come offline and chicken machines go down every third shift because you clean it all out.
Yes,
but now if you really want to move into the commodity production industries, you know, the sugar and the high fructose corn syrup and the citric acids and these type of things, we got to figure out how we maintain the upgrades in the systems on a routine, continuous basis. So, okay. Anyway, nope. Very good.
Yeah.
I'm all over the place, scattered with. So if you know the M-Guard, then you know the issues I ran into.
Oh yes. Also the 15-minute hack, I know that one as well too. So,
okay.
Yeah, and we look at security as core competencies. When I started EI3 in 1999, I knew controls, but I also knew that I didn't know TCP/IP well enough. So we hired a number of people from the New York City banking industry who were networking people who did interbank communications and things like that. And they helped us architect our solution. And it started out strong. Our appliance, we came up with an appliance, in 2001 was the first ones we delivered. And we're on our 5th generation of it now. So I think it's a core part of our value that we bring. And so when we talk about a managed secure network, we actually have a lot of machines, a fair number of machines with M-Guards that are connected to our network. But if you really want the true benefits, you go with the Amphion, and we can support, make that.
Okay.
Hey, Spencer, another topic maybe that you might want to cover is Stefan and the analytics group over in Switzerland. I don't know if you've...
Sure.
You have an analytics team?
We do. So we learned a few years back, now maybe about 4 years ago, we started working on projects where all of the data that we brought in, people would say, this data is great. We need to do our data science and analyze the data. And then they would come to us and they would say, do you know anybody? And we'd say, yeah, we work with this group in Europe. It's IBM's Watson team. And we would make referrals and had some good common projects and so on. But in the process, we developed a great interpersonal chemistry with this group of data scientists based in Zurich. And IBM, has their own thing. IBM is pursuing industrial internet, but these guys said, it might be better to leave the big blue world and go out on our own and team up with EI3 and then create sort of a symbiotic relationship with EI3, where EI3, as you said, we have a product. We're putting the product out there together with machine OEMs and integrators into different factories. But what if we also had a service, and that service would be data science for hire? And so we said, yeah, we'll help. We help them get into business. So we invested in the company. We're the major shareholder. We have the majority of the company. And they trade under the name of Cogsy, although we're probably going to, in the next 6 months, bring them in under the EI3 flag and make it, because we see that now that we have them as our partners in data science, we see that brings a lot of value, and a lot of people immediately start talking about what can we do with data science. We've just delivered a paper at the IEEE in Dublin, Ireland. The IEEE had last week a global conference on IoT, and we delivered a predictive analytics paper where we talked about applying Fourier analysis to vibration signals to predictively find machine problems. It's nothing that people don't know, but we're now doing it. We have a device which we call Symphony, which is based on the Amphion, that brings the vibration signals in and is using their machine learning algorithms to predictively stop a machine before damage occurs and things like that. So
okay.
It's a part of our customer journey that we would see, for example, hypothetically, let's say we did get involved with a Cargill, we wouldn't necessarily mention data science aggressively in the early phase of the relationship. We would mention how we can create the secure networking, get the right people to the right equipment at the right time, reduce downtime. We would mention our apps for downtime tracking, Pareto analysis, OEE, MTBF, MTTR. These are all no-code apps that we have that can sit on top of that data. And then once we have the database of those apps, then we would bring the data science team in and say, hey, are you doing enough data science with the data that we're giving you? Would you like us to help you? If the answer to those questions is yes, then we have the people available to make that.
Okay. Yep.
So
Spencer, to understand that, if your company had a relationship with another company, owner-operator company, after some number of months or years, whatnot, you have the capability for that to take that data from a process, from operating process, for instance, and say, okay, we as an owner-operator would like for your company to look at this data and see if you can understand or mine out trends or actionable data that will help us better control or optimize that process. Is that the idea?
100% correct, John. So let me give you an example. So we work with Lafarge Holcim,
Okay.
the largest cement making company in the world. And we have been able to save them in the DACH region. That's where we started, but now we're in Brazil as well. We're expanding. In Germany, Austria, and Switzerland, we've saved them $18 million a year of electricity and gas costs. And how did we save that? We saved it by monitoring their cement mills to understand the difference between a good cement mill operator and a mediocre and poor cement mill operator. And by understanding that, we've been able to create tighter alarm tolerances, which are adaptive to environmental. So now we're talking about the weather, the humidity, and the temperature of the place where the plant is, to make those mills react better to the certain weather conditions, so that we can get to the optimum good quality cement while using less energy. And we actually won an award by the Swiss Management Consulting Association for this 18 million in savings that we've been able to produce for these cement mills. So that same process could be followed with Cargill. If you have a replicable process which is being done at 50 or 100 or 1,000, whatever, mills of a particular type around the world, you will undoubtedly know that there's differences in those mills' profitability, and the difference might be because of something. It might be energy, it might be something else, I don't know. But we could frame the question in a way that would be understandable by the data scientists, who would then look at creating a baseline. We have a methodology, we call it the path to predictive. We would create a baseline based on the ideal. It's a digital twin, which is a mathematical description of what is an ideal mill's behavior given all of this certain input criteria. Once we've identified that digital twin, we then make sure that we have the instrumentation to monitor any mill, every mill, and see if it conforms with the digital twin. If it does, no alarms are set. If it doesn't, if it uses more energy or more raw material, waste, whatever, we set alarms. And if it uses less, we send a team of engineers in to go and learn why is this performing better than our expectation? And by doing that, we're able to save enterprises. Actually, Mark is probably going to kick me under the table here, but our best story about that is with Hilton. We actually have monitored the energy consumption and water consumption of every Hilton property in the world, 6,000 hotels. And we have more than 500,000 months of property performance data, which we've used to apply AI, machine learning, to come up with a digital twin. And then we monitor the hotels in real time to see if they're conforming, and if they are, okay. But if they're not, we alert people. And by doing that, Hilton has had a third party analyze the savings and have come up with a savings of $1 billion over the last 5 years by using our methodology to drive better behavior of property operations.
Well, that's really interesting because as it turns out, in business and industry, very few people understand the statistical side of data. And so we draw all sorts of conclusions from variations that are not statistically significant. We all have loads of data. So as you talk about that, that's a service that would be amazing, whether it's a distillation column or whether it's polymer reactors or whether it's a chiller in a chicken plant.
Yeah.
The ability to really figure out how to get the most bang for the buck would be really amazing and powerful.
Yes, we have a method that we apply. So the data science, there's the explore, discover, and run. So 3-step is like almost like 3 speeds. And if you have, and it doesn't necessarily, if you have data, so if you have OSI Pi, you have enough data, and you don't want to wait to get EI3 to become the custodian of the data, we'll work on other. Well. But at the discover phase, the team will come in. They will look at the data. They will talk to the operators. They'll talk to the managers who are responsible for the equipment, and they'll get a sense of what's going on. Normally, the discover engagement is like either a couple of weeks or maybe a month of consultant time. The output of that would be then a report that says, we've talked here, we've talked there, we think that, in the distillant column, these are the top 3 things that need to be looked at. We think we can build a model. We think to build the model, it's whatever it is, 4 staff months or 4 staff weeks of time. So an accurate proposal comes out, discover. Then the explore phase is we actually then take what we've proposed. We then build the model, deliver it to the customer in the form of an equation, which is running inside EI3. As soon as that equation is running, alerts are coming, which are based on the model. The plant or whomever is responsible has that operational awareness, so that however advanced it is, whether it's a simple threshold alarm, which probably isn't, or some highly interactive alert, which is based on machine learning or semantic analysis, we then run that in the cloud and we send those alerts out. Then the run phase is you may want to have a periodic every 6 months, a tune-up where new learnings, more data, tweaks are then put into it, and that usually is a couple of staff weeks of work. So it turns into where it becomes like a holistic engagement where there's the initial discovery, exploring, finding the models, running the models in the cloud, 1, 2, 3 steps. And yeah, we're very, very open to doing that. Sometimes we've seen where that gotten us in for the secure networking and the data products that we have. In other cases, we start with the networking and work our way to the data science. So it's a
we were getting ready to work. We were working on a model, and your cement industry reminded me of it. We have in our industry, along with our competitors, we have starch dryers. So we take cornstarch, and one of the most non-useful devices I've ever worked with is infrared moisture meters. Terrible to maintain, don't work.
Right.
Get them out of there. Very expensive and can't stay online.
Yeah.
So we worked.
Big thing.
So we started working with a data scientist group to say, what we want to do is take the data from this dryer.
Mm-hmm.
We want to look at everything around the dryer, including environmental.
Okay.
And we want to build a predictive model to predict the starch moisture within 0.1%, and we want to run as close as we can as 12, because if we run below 12, we're okay to sell it to the customer. But if we run at, say, 11.4 versus like 11.9, we could be selling 0.5% of water for the cost of starch. And so it improved our, and then that fed right back into the operator system screens. Okay. And that way they could say, I'm going to run it as the operator, or I'm going to let my machine tool run it. But this is where we had to develop the big brother, little brother. So what we did was we allowed the machine to generate the polynomials and what was a Laplace transform, basically. Okay. And then we would move that into little brother, and little brother, if they stopped talking, so it was constantly adjusting.
Right.
But when little brother couldn't talk to big brother, it said, okay, I'm taking over, and I am now going to still run. I won't get you the best tolerances, but I will keep you optimized as best I can with my latest data, but I'm not going to have all the big analysis. I'm just going to have the core algorithms running in me until I can talk again. And then once I connect,
otherwise, yeah,
I'll move all my data up, we'll reconnect, we'll resync, and then they'll input the data back to me again. So that was some of the developmental things that we were starting to work on with, and think about that. If you look at industry today, there's probably about 800 starch dryers out there or more. The other was these, remember those oil crush rollers we had, John, that were, man, if you could get those tolerances better and better and better, and we started to do just, and it was so difficult because one, we were tied up with the security, we couldn't move the data around. Two, data scientists were misunderstood within our system.
Sure.
And we had too many engineers that wanted to put them in Excel spreadsheets, and it was just so manual. It was so difficult to do. So there's some tremendous breakthrough capability in that continuous space. But that's just an example that when you talked about the cement,
you understand.
Starch dryers, roll crushers. I mean, yes, I'm very, very good in that. I didn't want to take everybody's time either. I mean, it's a wonderful talk. I'll talk the rest of the afternoon off. But
and I must apologize because I have a call that I need to start.
I know you. We didn't want to take your time away from. But very good.
Yeah. So what I like to say is that if you know of projects where you think our solution can be interesting, we're very interested to work with you and find ways to get it into the hands of the right people at the right place at the right time.